Hello, welcome back to the channel. So let's do another problem on these indefinite integral type of questions. So if you have not watched the previous video, I would highly suggest you to first watch those videos in order to get the full context of these videos, because we will be revising all those concepts that we did in the last video and using all those concepts in order to solve these type of questions in this video and in the upcoming videos as well. So in this question, we have to calculate the integral of 1 upon square root 2 minus x square. And as we did in the last video, as we discussed in the last video, that in order to solve these type of questions, you have to identify the pattern and pick one important integral function from the chart which would seem very similar to the integral, the indefinite integral you will be calculating for. So this is the first thing that you have to see. In order to, you have to see or you have to notice, because you'll most likely not have this chart, so you have to notice what is the pattern which I can use based on the chart. What is the pattern that I can use in order to evaluate this indefinite integral and simplify it down so that it matches with one of these important indefinite integrals. Don't worry if you still didn't get it. We will do this example and reinforce the concept that we discussed in the first half of the video. So now you see this indefinite integral, we have to calculate the integral of 1 upon square root 2 minus x square. So whenever you have this type of expression, this expression is the most similar to these type of expressions. The expressions which have 1 upon square root 1 minus something square. So that is why this indefinite integral is the closest one to our indefinite integral, and we just have to convert this indefinite integral into something like 1 upon square root 1 minus something square, and then based on the answer to that indefinite integral, we will write our answer and deal with the constants, deal with the extra constants that we have for the indefinite integral in our case. So let's try solving this question. So the indefinite integral is 1 upon square root 2 minus x square. Since I want under root 1 minus something square in the denominator, my first task is to convert this 2 into 1 so that I have the same pattern in the square root which starts with 1. So that is why the best approach to make that happen is, if I take this 2 common from the whole expression, I'll get a 1 at the start, right? So that is what we'll do in this first simplification part. So this would become integral 1 upon, if I take the 2 common, it would be 1 minus x square by 2, right? And the dx would remain the same. And now based on the chart, we know that we don't want any constants in our square root, so we'll take the constant out and outside the indefinite integral so that it does not interfere with our indefinite integral. So if I take this constant out, it would be 1 by square root 2, and then this expression would be in the square root, right? Like, let's simplify it down so that it makes more sense. I can write this as this expression, right? I can just split this expression and take the square root on this side and take the square root on this side and attach both of them together, right? So what I'll do is, I'll take 1 by square root 2 out such that it does not interfere with my indefinite integral answer. So now you see you have a similar looking pattern like 1 upon square root 1 minus something square. Now we have to convert this term, this whole term, into a square term. In order to do that, we will do the same process we did in the last video. We'll write, in order to convert x squared by 2 into a squared term, into something squared, we can write this expression as x upon under root 2 square, right? Because if I take the x upon under root whole square, it would at last be simplified to x square upon 2, and this would be dx. Now based on this expression, we know that whenever we have these type of expressions, when we have 1 upon under root 1 minus x square or 1 minus something square, the answer is arc sine of something which was in the square plus the constant of integration. So based on the pattern, the answer The first initial guess for us should be 1 by square root 2 because it would not change. This should become arc sine x by under root 2 plus c. But now again we missed the important part of considering the chain rule. So that is why we'll have to consider it. And as we discussed in the last video, the easy trick to do that is whatever constant you have in front of your x, in front of your function, you'll take the reciprocal of that constant and attach it to the expression again. So in this case, since the constant is 1 by square root 2, we'll take the reciprocal of 1 by square root 2, which is square root 2, and attach it to the answer. So it would be square root 2 times whatever answer we had in the previous case, right? And now if we simplify this further down, this root 2 will get cancelled out to this root 2, and the answer would be arc sine x by root 2 plus c, or sine inverse, because arc sine is sine inverse only, so it would be sine inverse x by root 2 plus c. So that's it for this video. In this video also, we discussed two important things. The first thing is to identify the pattern and then convert our indefinite integral based on the pattern that we look for in the important indefinite integrals chart. And the second important thing was to also consider the chain rule. Whenever you have a constant attached to your x, you'll take the reciprocal of that constant and then attach it to the integral or the general answer to your indefinite integral. And also at the last, please don't forget to add the constant of integration when you are calculating indefinite integrals. That's very important to do that. If you don't do that, some markers will definitely deduct some points off from your final answer. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.